Okay, so we've got a basic titration problem here. It's the question's telling us in a titration 26.4 cubic centimeters of 1 molar hydrochloric acid reacts with 25 cubic centimeters of sodium hydroxide. The question is, what's the concentration of the sodium hydroxide? What you've got to look at here is the kind of things we're dealing with. So if you look carefully at the question, we're dealing with a volume, another volume, and a concentration. This should give you a clue. So what we're going to be using is this equation. CNV is our equation triangle, and you've seen this in lessons. So draw the triangle at the top of any question like this. It's always useful to have. Remember, C is concentration in moles per cubic decimeter, N is number of moles, and V is volume. The key thing about volume is getting the units right. Up here we've got cubic centimeters. Whenever you use it in this equation, in this context, you have to use volume in cubic decimeters, and we'll deal with conversion in a little minute. The thing you have to do in these situations is always write the equation if possible. So we've got HCl reacting with sodium hydroxide, NaOH. Year 7 chemistry, acid plus a base gives us a salt, in this case sodium chloride plus water. And now look at your equation, look at what you've been asked in the question. The things we're dealing with here are HCl, 1 mole per cubic decimeter concentration, and sodium hydroxide. So these are the two things we're interested in. So let's look at the molar ratio of these things in an equation. Always a good idea to write it down. In this case, it's a nice, simple, easy one. The molar ratio is 1 to 1. Now let's consider what we already know from the question about the hydrochloric acid. So the first thing we're going to do, we can look at concentration and volume, C and V. We've got these in the question, so we can work out N. Always advisable to work by writing things down. Concentration here tells us in the question is 1.0 moles per cubic decimeter, and notice I'm writing all the units out as I'm doing this. Volume from the question is 26.4 cubic centimeters, but we've already said the volume has to be converted to cubic decimeters, so to do this just divide your figure in cubic centimeters by 1,000. Push the buttons on your calculator if you need to, and this turns this into 0.0264 cubic decimeters. Now we have C, we have V in the correct units, which means we can work out N using the formula triangle. N equals C times V, which in this case gives us 0.0264 moles of hydrochloric acid. So all we've done is plug these numbers into the equation and got our... Now we can get to answering the question. What we've been asked for is the concentration of the sodium hydroxide. So what can we do about this? Same game, write down what we already know. C, well, that's what we're trying to work out. So that's our question mark, but we also know C is equal to N over V from the equation triangle. So we'll leave that for now. Let's see what else we know. Do we know V? Well, if you look up in the question, yes, we do. We know that the volume used was 25 cubic centimeters, but again, take care, units. We must have volumes in cubic decimeters. Same procedure, divide by 1,000 and convert to 0.025 cubic decimeters. Now this is where we can use the molar ratio we worked out earlier on. We can use N from above. We know it's a 1-to-1 ratio, so if we use 0.0264 moles of hydrochloric acid, that converts nicely across, and we know we must have used 0.0264 moles of sodium hydroxide. Now if you take a look at what we have N, we have V, and we can take these numbers now and plug them into the equation above to solve our problem. And that's what we'll do. It's a simple case of transferring the numbers, and I always think it's a good idea to write things out fully, show the units of everything you've used, and it's fail safe. You can't go wrong. So all you then do is plug these numbers into your calculator and get the solution to the problem, which in this case gives us 1.056 moles per cubic decimeter. Notice the units have a minus here because we've done moles divided by decimeters. And that's it. That's how to solve a basic titration calculation.